Section 6.3 example 6 on page 435 says sometimes a denominator is a sum or difference involving radicals. If the radical expressions are square roots, you can rationalize the denominator by multiplying the numerator and the denominator by the conjugate of the denominator. So example 6 says, how can you write the expression 3 radical 2 divided by the square root of 5 minus the square root of 2 with a rationalized denominator? Notice the previous slide specifically mentioned square roots, so it's not any type of radical. We can only use this idea if we're looking at square roots, because the method that we learned with conjugates in the previous problem is going to work for our square roots. So a note, we want to look at the denominator. We have the square root of 5 minus the square root of 2. That is a difference of square roots. So the conjugate of that is going to be the sum of those same square roots. So square root of 5 plus the square root of 2 will be the conjugate of our denominator. We want to use this to simplify our expression. Right now, we have radicals in the denominator, which means this fraction is not simplified. So to fix this, we are going to multiply by the conjugate on both the top and bottom of the expression. Reminder that when we multiply by radical 5 plus radical 2 over radical 5 plus radical 2, we're really just multiplying by 1. So we aren't changing this expression. We're just going to rewrite it so that it's simplified form. All I did right here was put this as one big fraction, so 3 radical 2 times square root of 5 plus square root of 2 over the square root of 5 minus the square root of 2 times the square root of 5 plus the square root of 2. The numerator we're just going to distribute, but in the denominator we can actually use the shortcut that we talked about in the previous problem. So when you're multiplying conjugates, all you have to do is square the first number, square the second number, and subtract the 2. So in the numerator, we're going to take this 3 radical 2 and multiply it into the parentheses. So we have 3 radical 2 times radical 5, which we have over here, and then we have a plus sign. We're going to take our 3 radical 2 and multiply it by the radical 2 that's already in there. So that gives us 3 radical 2 times another radical 2. And then on the bottom, using the shortcut, if we square a and we square b with our minus sign, we get 5 minus 2, or we're going to rewrite that as 3. If you don't understand where the 5 minus 2 came from, go ahead and make a quick box off to the side, do some scratch work, use foil if you like foil, but you will end up getting 5 minus 2. That is the entire point of the conjugates. It will always work like that. So here we have 3 times the square root of 2 and the square root of 5. They're both square roots, so we can go ahead and multiply those together to get the square root of 10. So this will become 3 square root of 10 plus, now we have 3 times the square root of 2 square root of 2, again, both square roots, so we can multiply them together to get the square root of 4. And then on the bottom, we had just 3 from the 5 minus 2. The next thing I want you to notice is that every single term has a 3 in it. So that means we can simplify the fraction by getting rid of the 3. If this is a little bit tricky for you and you don't like simplifying fractions this way, you can also separate this into 2 fractions, which might make it a little more obvious. So remember that when you have addition or subtraction in the numerator, you can separate them into 2 fractions. So now we would have 3 radical 10 over 3 plus 3 radical 4 over 3. So you keep the denominator, but you can split up the numerator. Now we have 3 on top, 3 on the bottom. They undo each other, we get a 1. 3 on top, 3 on the bottom, they undo each other, we get a 1. If you notice that up here, you don't have to write this out. I just wanted to make it a little more clear that this is how we're going to get the fraction to go away. Now we want to look at our radicals that we have left. We have the square root of 10. 10 is not prime, but if you break it down with a factor tree or just in your head, you get 2 times 5. Neither of those are perfect squares, so we're going to leave it as radical 10. However, 4 is actually already a perfect square, so hopefully this one's familiar. Square root of 4 is just 2, and that right there is going to be your final answer. So the simplified form of 3 radical 2 over the square root of 5 minus the square root of 2 is just the square root of 10 plus 2. The work for this problem is written out on the next few slides. And now I would like you to try number 10, rationalize each denominator, simplify your answer. 4 divided by 1 plus the square root of 3.